Welcome and welcome to my page. Today we are going to look at indices equation to continue on our laws of indices. Indices equation still the same thing as exponential equation of indices. And with me here are some few questions that I'd like to treat with us. So let's take them one by one and see how we can apply it in our little mathematical problem. So solution. Let me take number one. We have 4 raised to the power of x is equals 64. In this case, we have 4 and we have 64. 4 raised to the power of something will give us 64. And that is what? 3. So we have 4 raised to the power of x equals 4 raised to the power of 3. Base equals base, comma, equate powers. So when you have this kind of situation, since base is equals to base, 4 is the base, 4 is the base, then we now equate the powers. That means x is equals to what? 3. We'll solve the problem. So number 2, we have 8 raised to the power of x equal 0.25. Convert this one to fraction. We have 8 raised to the power of x is equals to 25 all over this point 1, 1, 2 becomes 2 zeros. So what do we have? We go further by reducing this fraction to the lowest term. 25 here 1, 25 here 4. And so we have 8 raised to the power of x is equals to, you can write this one in another form. In indices, we should have 4 raised to the power of minus 1. And therefore, there is something you can raise 8 to that will be similar to the base. You can raise similar thing to 4. Like 2 raised to the power of 3 is 8. So 2 raised to the power of x, all in bracket x, is equals to 2 raised to the power of 2, all in bracket minus 1. So we have 2 raised to the power of 3x equals 2 raised to the power of minus 2. 2 multiplied by minus 1 is minus 2. Like I said before, base equals to base equate powers. And therefore, we have 3x equals to minus 2. Divide both sides by 3. We should have 3x over 2 over 3 plus minus 2 over 3. And give us 3 cancel 3. We have x equals minus 2 over 3. That is your answer. It's as simple as that. So we also have another one. Number 3. We have 2 raised to the power of x equals 1 over 8. This is just similar to what we have done. change this one back to its form. We have 2 raised to the power of x is equals to is equals to 1 over 8, which can be written as 1 all over 2 raised to the power of 3. And therefore 2 raised to the power of x is equals to 2 raised to the power of minus 3. We change it to this form. Now base equals base equate powers of x is equals to minus 3. It's as simple as that. As simple as that. So let's take number 4. We have number 4. Number 4. Number 4. We have 5 raised to the power of x is equals to 1. In indices, anything raised to the power of 0 is 1. And so since we have 5 here as the base, we make 5 the base here, which is 5 raised to the power of x is equals to 5 raised to the power of 0. Base equals to base, equate powers. Therefore, your x is equals 0. It's as simple as that. There's no big thing there. Also, let's take number 5. Number 5, we have 3 raised to the power of x equals 27. 27 raised to the power of x minus 1. When you have something like this, you find 3. 27 power, something raised to power, 3 raised to the power of a number will give you 27, which is 3x here, because 3 raised to the power of 3 is 27. So that solves the whole problem. You have your 3 raised to the power of x equals 3 raised to the power of 3x minus 3. Base equals base, equate powers. Therefore, we have x equals 3x minus 3. In this case, we collect the like term, alphabet to one side and the number to one side. So we have 3 should come. We have x minus 3x is equals minus 3. X minus 3x, we have minus 2x, which gives minus 3. Divide both sides. Divide both by minus 2. Now I have minus 2x over minus 2 equals minus 3 over minus 2. Minus cancel, minus 2 cancel, minus 2. You have x equals to 3 over 2, which can be simplified as 1 whole number 1 over 2. That gives the answer. So simple as ABC. Anywhere you find similar question, don't be scared. Don't be scared. It is very easy to attend to. And also, let's take on number 6. Number 6. Number 6 is 2 raised to the power of square root of 2x plus 1 equals 32. And so from here, you look at 2 raised to the power of something, will give you 32. So keep this one constant. 2 raised to the power of 2x plus 1 will be 2 raised to the power of 5, will give you 32. If you are confused, you can look for the factor like 32. You divide 2 here, 1, 6, 2 into here, 8, 2 goes to this, 4, 2 again, 2, 2 here, 1. So when you count 1, 2, 3, 4, 5, that is 2 raised to the power of 5. That is what it's all about. So from here now, base equals to base equate powers. So we have square root of 2x plus 1 equals to 5. Square both sides. Square both sides. Now have square root of 2x plus 1. Everything is square. And you have 5 square. So this one cancel this. Or you can change it to 2x plus 1 in bracket raised to the power of what? 2 multiplied by raised to the power of half multiplied by 2 equals 5 raised to the power of 2. So 2 cancel 2. You have your 2x plus 1 equals 25, because 5 squared is 25. You solve your ordinary linear equation. 2x equals 25 minus 1, which is what? 24. So your x now will be 24 all over 2, which gives you 12 as your answer. It is very simple if you follow it step by step. On the next video, I will be treating an exponential equation of indices involving quadratic equation and also simultaneous equation. Thanks and bye.